All right, properties of logarithms. So logarithms have properties just like exponents have properties. So I need you to remember your exponent rules so that you can know your log properties. So when you have right here your first rule of exponents here, when you multiply things with the same base, if you remember, you add the exponents, right? Like if you had, for example, x squared times x to the fifth, you get x to the seventh, okay? So the logs have a corresponding rule. So you have to remember that addition and multiplication are tied together. So when you see the log of an item plus the log of another item, addition is multiplication. Multiplication is addition. So this can condense into one log, and you just take those two items, A and B, and multiply them. Okay. Here, division. When you divide, like when you say x to the fifth divided by x squared, you subtract them, x to the third. So subtraction, division. So x to the a minus b. So that turns into this. When you have log of a minus log of b, subtraction, division. So that can turn into the log of a divided by b. And all this is this. Like, let's say you had the log of 12 minus the log of 3. So we know that's equal to the log of 12 over 3, which is 4. So if you were to type this into a calculator, you would get the same thing as this. All right, so it's just like a rule that it just works that way. But just those are properties of logs. Like subtraction can turn into division. The bases have to match and everything, but we're just assuming these are both base 10 and all here too. All right. So last little rule to remember, when you have a power of a power. So if you had x to the 2 to the fifth power, remember you multiply those exponents, right? So x to the a times b. So that turns into this. If you had log of a to the b, that could be turned into, if you want, that b could be brought to the front as a multiplier. So you bring the b in front, and then you have log of a. All right, so sometimes in problems, so people don't go around just like condensing and expanding logs just because they want to. They do it because sometimes when you see a bunch of logs like spread out like this, you want to write it as just one expression, log base 4, and then you want to have one thing here, all right? Because you use it when you're going to solve equations, which is in the next little section that we're going to do. Like all these, you want to condense them into one log. So you do more condensing, but every once in a while you also have to expand. Like for some reason, like if you expand this out into all the parts that all the logs it could be, maybe one of them will be useful to you. So you do more condensing, but let's just see how it goes. But you have to know how to do both. All right, so this one's easy. Subtraction turns into division. But right before I do that, this 3 can be an exponent. So it's going to be 2 to the third. So I like to just cross it off and put it, so it's 8, right? So it's going to be log base 4 of 32 over 8. Well, that's 4. So log base 4 of 4. Now this is suspicious, right? Do I know 4 to what power makes 4 again? And I do. So this is equal to 1. So that could be my final answer, right? 4 to the 1 is 4. So this actually can reduce down to 1. All right, over here, anytime I have an exponent, it's going to go up top. So it's going to be a 6 here. This 5 is going to go around all of this. And the last one doesn't have one. Okay, so here we go. So I got log base 2 of x to the 6th, log plus log base 2. That's going to be 2 to the 5th. That's 32, y to the 15th, minus log base 2 of x to the 4th. Okay, so I'm going to write this as one log, base 2. So it's important to notice here I have x to the 6th, I have this expression, and then x to the 4th. Those are the pieces that I'm going to write after log. So I have x to the 6th, it's plus, so that's times 32, y to the 15th, and then the minus is divided by, so divided by x to the 4th. So when I'm done here, let's just reduce these. X to the 6th and x to the 4th. This makes 2. And I think I'll just write my answer. Log base 2, I'll put 32, x squared, y to the 15th. And that's it. I don't have a denominator. All right, over here. So this 2 is going to be distributed to both these problems. This 3 is going to be up here. So I have log base 5 of x to the third minus, it's a negative 2, so it's going to be minus 2 log base 5 of y to the fifth, and then be minus 2 log base 5 of z squared. All right, so let's apply this 2 here. So remember, this 2 is an exponent. So that's going to be log base 5 of x to the third minus log base 5 of y to the 10th. And 2 goes up there, so that's going to be minus log base 5 of z to the fourth. All right, so I have to put these 3 pieces in an expression. So I'm going to have log base 5 written one time. I have x to the third, and these next 2 parts are both minus. So they're both going to be divided underneath the x to the third. So over y to the 10th and z to the fourth. And there you have it. So that was one more. All right, so this 3 goes up here. This 1/2 goes there. So I have log, and this is base 10 basically, x plus 4 to the third over x to the 1/2. Now you could write it like this, or you could write it as log of x plus 4 to the third, and that could be the square root of x. Remember, either one of those is acceptable. All right, now here we're going to be expanding. You don't do this as often, but sometimes. So we're going to basically do backwards of what we did before. I need to see this part. This is 1, 2, 3, and that c squared is my 4th piece. So this is going to break out into 4 different logs. Okay, so I'm going to have log base 5 of 4. It's times a to the 7th, so plus log base 5 of a, that 7 can go in front. Now the next 2 are underneath, so it's going to be minus log base 5 of 5, and then again minus log base 5 of c squared, but that 2 can go up front. And the only change I would make is this, log base 5 of 5. 5 to what power makes 5? Well, that's 1. So this could be replaced with a 1. So anytime you have a base and the expression you're doing the log of match, like if you had log base 4 of 4 or log base x of x, like it all equals 1 all the time. Okay? All right. So next one. Okay, so you have an option here. You can bring this 2 out to the front now, or I can just apply the 2 to everything in here. So this is log base 4 of 9 x squared, y squared, z squared. And so when I'm done looking at this, I have 1, 2, 3, 4 things. So I got 4 logs. So log base 4 of 9, they're all multiplied, so plus log base 4 of x squared, but that 2 can go here, plus log base 4 of y, but the 2 can go here, plus log base 4 of z, and the 2 can go up front. Okay? All right, over here, I have 2 items, basically. All right, I have the 4, and I have the rest. So I'm going to have log of 4 plus, because they're multiplied, log of 2x plus 1, and that's to the 5th, so the 5 can come out front, and that's finished. All right, here I have the 3, and I have the square root of x minus 5. Now remember, the square root of x minus 5 is x minus 5 to the 1/2. So I got log base 3 of 3 plus log base 3 of x minus 5 to the 1/2, and so I put the 1/2 out here, and also log base 3 of 3, that's equal to 1, so really I have 1 plus 1/2 log base 3 of x minus 5, and that is the best way to write that.